Hey developers, when you're building AI-powered applications, choosing the right large language model and tuning its parameters can dramatically change the output you get. But figuring out how different models behave and how parameters like temperature or top P influence responses can be time-consuming without the right tools. In this hands-on video, we'll explore a simple framework that lets you compare two LLMs side by side, each with its own set of parameters, all powered by the Qualcomm AI Inference Suite running on Qualcomm Cloud AI accelerators. By the end of this interactive session, you'll understand how tuning choices influence LLM behavior, and you'll be able to compare your models using our comparison tool. Let's get started by understanding the challenges of working with LLM models. With most closed-source AI platforms, customizations options are limited. Maybe you can pick a model, maybe adjust the tone, but that's it. But with open-source models, especially those accessed through APIs like the Qualcomm AI Inference Suite, you have granular control over generation parameters. The primary obstacle developers face is understanding these parameters and choosing the right settings for their needs. We created this comparison framework to make that easier. This framework allows you to compare two LLM models or parameter configurations side by side, test them using the same prompt for reliable analysis, and at any provider that supports the OpenAI compatible API. Before we run the comparison tool, let's review the most important parameters you'll be tuning. First, we have max tokens. This refers to the maximum amount of text the model is allowed to generate. If the value is set too low, the response may be cut off prematurely. Setting it higher ensures complete answers, but can produce unnecessary output, increasing cost and processing time. This parameter is especially useful when you expect short, structured results. Next, we have temperature. Temperature controls the randomness and creativity of the model's output. The value of 0.0 produces consistent, deterministic answers, while a setting of around 0.7 encourages more creative and varied responses. Higher temperatures increase expressiveness but reduce predictability. Another configuration option is repetition penalty, which helps the model avoid repeating the same phrases over and over. Values below 1.0 can lead to loops, while values that are too high may reduce coherence. A default of about 1.1 typically provides balanced, natural-sounding output. Next, we have the parameter top P. Top P nucleus sampling restricts the next token choices to a portion of the highest probability options. Higher values allow for more diverse wording, while lower values lead to more conservative, factual responses. Finally, top K limits how many tokens the model can consider at each step. Increasing this value promotes creativity, while decreasing it results in more focused, deterministic output. Now, let's walk through the full hands-on portion using our open source sample. Open your terminal and clone the repo. Before going into your files, create an account at Surscale and other providers and make a note of your API keys. Once you have the repo on your machine and you have your API keys, open your endpoint configuration JavaScript file. Enter your API keys for all the providers in the JS file. Now that you have updated the endpoint file with your API keys, you can start using the comparison HTML file to compare different models and experiment with parameter settings. Let's open the HTML file from our repository in a browser. Once you open the HTML-based tool, you can see the providers we have as an example and the models that you can choose from based on the provider. You will also see the parameters that we'll be working with when we compare the results. Pick two different models from the Surscale provider in each of the configuration displays. Let's pick Llama 3.3 70B for Model A and Llama 3.1 8B for Model B. The first model should be a little slower because it is the 70 billion model, and the second should be a little faster since it is a smaller model. Let's see how the models act with two different types of prompts. First, let's try a creative prompt. Write 10 social media taglines for a futuristic smartwatch. After comparing the results, try a more structured prompt. Summarize the following paragraph in 2 sentences. Seeing the outputs side by side makes it easy to compare the output of different models. Now let's try a creativity test by changing some parameters. For Model A, change the temp to 0.1 and the top P to 0.2. For Model B, set the temp to 1.0 and top P to 1.0. Then describe a marketing task. We can also use the same model and use the same variation in parameters, and we also see that we get different results. You can also experiment with the max token parameters and see how it changes the number of words in the output depending on the max token's value. Let's explore how changing the top K values can influence the model's creativity. Set the top K in the first model to 5, and set the top K in Model B to 200. To see variation in the outputs, make sure the temperature is higher than 0 for each model. Let's see how the two models describe the ocean. As you tweak parameters, you'll notice that high temperature top P and top K values produce far more expressive, varied, and sometimes surprising responses. This is ideal for brainstorming, creative writing, or marketing style prompts. Low values across these parameters create tightly controlled, predictable, and more factual output. This makes them perfect for summarization, classification, and technical tasks. Repetition penalty determines how disciplined the model is. Too low and it may loop or echo itself, too high and the model may lose coherence. Even when using the same prompt and identical settings, different models can diverge significantly in tone, detail level, reasoning quality, and vocabulary range. This hands-on testing is the fastest way to learn what works for your use case. You now have a flexible, practical tool to compare two LLMs, compare parameter sets, validate prompt tuning, understand model creativity versus determinism, and explore how open-source LLMs behave under different constraints, all using the Qualcomm AI Inference Suite's OpenAI-compatible interface. Continue experimenting further with model comparison using the framework yourself. Customize the configs, test prompts that matter to you, and compare multiple models or endpoints. You can also change the endpoint configuration file to sample LLMs hosted by different companies. Share your findings with the community on the Qualcomm Cloud AI Discord, and don't forget to sign up for free tokens through ServerScale. Thank you for watching, and stay tuned for more tutorials using the Qualcomm AI Inference Suite.